Welcome, students. We're going to be doing section 3.7, still more on linear equations. We're going to be doing applications with percent problems, discounts, taxes, commissions, profits, and other things. So this is like daily living. We're going shopping, we're going to pay our taxes, we're going to be working for commissions. So here we go. So first of all, we're just going to review changing decimals to percents and changing percents to decimals. We're going to find percents of numbers and find fractional parts of numbers and then solve word problems involving decimals, fractions, and percents. So we need to remember this basic formula. This is the rate times base equals amount. Now the word amount can stand for several different things. The A can stand for commission. It could stand for taxes. It could stand for discount. So there's lots of things that it could stand for. These are just like three basic ones that we would be looking for, okay? But you have the rate, that's always a percentage. The base is basically the cost of an item, and then we take it and we find its discount. Or the word of, just as a reminder, means to multiply, and is means equal. So this is where we really see the word is being used as an equal sign. Okay, so rate times base equals amount. So what is 72% of 800? So what represents a variable? Is equals 72%. I'm going to write it like this because percent means parts of 100. Of means times, and so we're going to times 800. And that's basically how you would set that up. If we're just converting from English to math, what is the variable? 72% can be written as this fraction, and of is a multiplication, and 800, and then of course is the equal. So that is what we're trying to find. Okay, so just looking at our words and we're learning to create our sentences from them. So our rate is 72%, our base is 800, and A is the unknown. Okay, so what is 72% of 800? And we just multiply that through. 72% of 800 is 576. So let's say that you got 72% of your sales as your salary. Then you'd make, if you sold $800, maybe you got 576. You wish that was your job. But you know, I have a friend who actually works for Neiman Marcus, and he sells shoes. And some of the shoes that he sells are like worth $20,000. And if he gets a 20% commission, he's just getting $4,000 right there on that shoe. So pretty impressive. All right, let's look at this one. 57%. The of is our times. What number? We don't know that. Is 163.191. This is our amount. This is our rate, and our x has become our base in terms of that formula. All right. So go ahead and we'll solve that. In this case, we're going to divide by 0.57, and it's going to be 163.19. Now, just as a reminder, 57% is the same as 57 over 100. And if I do the math for that, that makes it 0.57. And that's where that 0.57 is coming from, converting a percent to a decimal. And so 57% of $286.30, or whatever the number is 163.191. So what percent? This time we're looking for something percent of multiplying 180 is 45. So what percent of 180 is 45? Well, we're going to divide both sides by 180, aren't we? And we're going to find out that it's 25. And now that is the decimal, but if we're going to have to write it as a percent because it wants to know the percent, we then have to times it by 100 and it becomes 25%. And you need to be used to doing these things, changing from decimal to percent and percent to decimal. Okay? So a bicycle was purchased at a discount of 25%. Now remember, I said rate times base can equal amount, but amount sometimes is also the word discount. So if we want to find the discount of something, we take the discounted rate times it by the base amount, and that will tell us the discount. Okay. So here we have a bicycle was purchased at a discount of 25%. So we know R, and its original price or its base price was $1,600. Then, now this one gets pretty deep and sticky. Then we go up to the counter. So we're going to get 25% off of $1,600, which is $400, right? So we're really paying $1,200. But then they're going to add a sales tax onto that. So what was the total paid for the bicycle? So there's several parts to this. First of all, we need to discover what is the discount. Well, that would be 0.25 times 1,600. And I already told you that that was $400, right? Then you take the original price and you minus the discount, and that will give you the sell price. So we take our 1,600 and we minus the 400, and that gives us our 1,200. Then we're going to times the sales tax. The way it works is you get your total of your goods purchased, then you times it by 6%, and that will give you your tax, which is going to be $72 in this case. Okay, so we're going to have 1,200 plus the tax is the total price. So in this case, our rate was 0.06, our base was 1,200, and our tax, that's going to equal our tax. We decided that that was $72, right? So 1,200 plus 72 equals 1,272. And that's how that one would go. They're going to show you a different way that you can do it too. And it's kind of a step saver in a way, and we'll look at that. So there are two ways to approach this problem. One way is to find the discount. That's what we did. And then subtract this amount from 1,600. Another way is to subtract 25% from 100% to get 75%. And then you take 75% of 1,600, and that will actually tell you the sell price. Okay. And then either way, you have to calculate the sell price, the tax of the sell price. So here what they do, rate times base. 0.25 times 1,600 is $400 discount. So the original price minus the discount is 1,200. Then the tax on 1,200 would be 0.06 times 1,200, which equals 72. So the total price is 1,200 plus 72. So you're going to pay $1,272 for that bicycle with that $400 discount. The second way that we could have done it is just to have done 0.75 times 1,600, and that would have gone right to the 1,200 without doing this subtraction problem, because it was 25% discount. That would leave how much left over? Well, 100 minus 25 is 75. So the bike's 75% of this, and then we don't have to do that subtraction problem with the discount. But I kind of like for us right now to just stay with finding the discount, then finding the tax. Okay, a saleswoman earns a salary of $1,200 a month. So that's where she starts, plus commission. So 1,200 plus commission equals her salary. Okay. A commission of 8%. Oh, so her commission, remember, commission could be another word for the amount. So the rate times the base equals her commission. And she's getting 8% of what she sold, or not quite, but we're going to write that as 0.08. But she has to sell 8,000 first in furniture. So what did she earn the month she sold 25,000? Well, remember, the first 8,000 she doesn't get 8% on. So what's left over after she's the first 8,000 from the 25,000? You would get what, 13? No. Yeah, 13,000. No, 17,000. Sorry. I think 17,000. So the base that the commission is going to be is 17,000. Here, I just need to do 25 minus 8. We'll get that. That's 17 there, 17,000. Okay, so the rate of commission times the amount of money that she gets to use for the commission will equal her commission. So we're going to have 0.08 times 17. That will give us our commission. We then add that to her monthly salary and we'll know her base salary. And this is her total salary over here. Okay, so let's go ahead and watch this being performed. So first we did the 25,000 minus 8,000, giving us 17,000. And now we're going to find the commission, which is 1,360. And now we add that commission to her base salary, 1,200 plus 1,360 is 2,560 a month. So that's what she's making. Okay. Now we're going to calculate the percent of profit for both A and B and tell which is the better investment. There's a $300 profit on an investment of $400 and a $500 profit on an investment of $500. We're going to see which had the best interest rate is what we're looking for. So we're going to set up these ratios. $300 profit for $2,400 invested. And if we reduce that down, that's 1/8 or 0.125% or 12.5%. Sorry, not 0.125%. The decimal 0.125 or the percent 12.5. And the other one, if we check it, that's 1/10 or 0.1 or 10%. So the investment at 12.5 is greater than 10% investment. Okay, so A is the better investment rate. That's what they should say, not necessarily the better investment, but it has the better investment rate. So we're going to write these, we're going to do these problems. So take a moment, pause the video, see if you can do these problems. All right, let's begin. 0.3 as a percent, 0.3 as a percent, that means I'm going to move the decimal twice to the right, and that will give me, and filler zero in is 30%. 6.4% means I take the 6.4, and since I'm going from percent to decimal, I go to the left twice, put my decimal there and a filler zero, and I get 0.064. 1/5 as a percent, well, that's 0.20, which then is 20%. Find 12% of 200. Well, that would be $24 because I just 0.12 times 200, and that would be $24 or 24. And find the percent of profit if 400 is made on an investment of 1,500. So we could do the, and that, I want to show you the equation, how they got that ratio. Remember, rate times base, in this case, equals the profit. So the rate, we don't know. That's what they want us to find. The base is 1,500, and we know it's going to equal 400. We're timesing that. So if I want to know X percent, I'm just going to divide both sides by 1,500. And that's how they got that ratio in that last problem. So we actually have 4 over 15. And if we want to find what that is, we just use our calculator. 4 divided by 15, and I don't have a calculator with me, so we'll just kind of look and see what we get. And it would turn out to be 26.67, but you notice we had the 30%, the 0.064, 20%, 24, and then 26.67%. So go ahead and do your derivative problems today. Practice turning percents into decimals, decimals into percents, and working those ratios. Thanks for your attention and have a good day.